Have you ever wondered what really happens when a Tesla's battery hits zero? Does it just shut down, leaving you stranded instantly, or is there some kind of secret backup? This is the #1 fear for anyone even thinking about an EV, range anxiety. But how much of that fear is legit, and how much is just myth? Today, I'm pushing my Tesla to its absolute limit to find out. We're not just hitting 0%, we're going to keep driving until the car completely gives up. We'll see what warnings pop up, what systems fail, and if you're truly left helpless. This is definitely something you shouldn't try at home, but I figured someone had to do it. Let's see what happens. Alright, here's the game plan. We're starting this experiment at a level that would make most drivers sweat. 20% state of charge. But we're not heading to a supercharger. We're driving on a safe, closed-off road, away from traffic, until this car is done. I've got a support vehicle with me, a portable jump starter, and everything we might need for a recovery, so we're being as safe as possible. The goal is to document every single stage of a Tesla's battery life ending. We'll see every warning, feel every change in performance, and get to the bottom of what happens when the lights go out. First, it helps to know there are 2 batteries in a Tesla. You've got the huge high-voltage battery under the floor that runs the motors. That's the one we're draining today. But there's also a small 12-volt battery, like in a gas car. It powers the essentials: the screen, door locks, windows, and the car's computer. The big battery keeps the 12-volt topped up. So, the real question is, what happens to those critical systems when the main battery is totally gone? Does the car just become a brick? Let's start driving and find out. So, we're on the road, and the battery is dropping. Right now, everything feels totally normal. The car is smooth, quiet, and quick. You'd have no clue we're on a collision course with zero. Okay, we've just dipped below 20%, and the battery icon at the top of the screen has turned from green to yellow. This is the car's first gentle nudge, pretty much like a gas car's fuel light coming on. A message has popped up suggesting I navigate to a charging station, which is helpful, but today, we're ignoring it. As we keep driving, the percentage keeps ticking down. 15%. 12%. The car still drives perfectly. Acceleration is there, and the climate control is working fine. For any normal driver, this is your sign to find a charger, and the car's navigation makes that incredibly easy to do. Now we're crossing the 10% mark. The battery icon is red, and the warnings are getting a bit more serious. A new message reads, "Battery power very low. Car may shut down." On the power meter, I'm seeing a dotted yellow line appear. That line shows that the car is starting to limit its peak power output to save energy. I can still get going quickly, but if I were to floor it, I'd notice it's not quite as punchy. Regenerative braking also feels a little weaker, since the battery has less room to store recaptured energy. This is where the real psychological range anxiety kicks in. The screen is giving you red warnings, and the car is telling you it's about to shut down. But here's the thing, it's not. Not yet. This is all part of a very deliberate warning system designed to get your attention and make sure you never end up where we reheaded. We're at 5%. The car is now strongly telling me to charge immediately. The power limit is much more obvious now. That dotted line on the power meter is bigger, and when I push the accelerator, it feels a lot softer. The car is holding itself back, choosing range over raw power. 3.2.1, and there it is. The display shows 0%. But here's the crazy part. We're still moving. The car is still driving. This is the much talked about hidden battery buffer. It's a small reserve of energy kept below the 0% mark to give you one last chance to pull over safely. But how far can it actually go? Right away, the car feels different. There's a clear warning on the screen. Vehicle shutting down. Pull over safely. Acceleration is heavily restricted. My foot is almost to the floor, and we're just gently cruising in a limp mode. Top speed is limited, and it's a struggle to get over 25 miles per hour. We've now driven a couple of miles past zero. The car is still going, but it's on its last legs. The power limit line has taken over almost the entire meter. Any system that isn't essential for driving is being cut. The heating and air conditioning are off to save every last electron for the motors. We just passed 3 miles past zero. It's honestly impressive. The anxiety is real, but the car just keeps rolling. Some tests have shown this buffer can be anywhere from a few miles to over 20, but it all depends on your model, the weather, and how you're driving, so you should never count on it. We are now several miles past the 0% mark, driving on a battery that should be completely empty. If you're finding this experiment as nerve-wracking and fascinating as I am, do me a favor and hit that subscribe button. We are about to see what happens when this hidden reserve finally runs out, and you won't want to miss what comes next. Okay, something's happening. The car is chiming, and the accelerator pedal is going dead. We're losing speed, even with my foot down. The car is slowing down gently, giving me plenty of time to get to the side of the road. A final warning appears, letting me know the vehicle can no longer drive. And that's it. The motor is off. We're rolling to a silent stop. the car automatically shifts itself into park. The main high-voltage battery is officially done. So, are we totally dead? Not quite. The main screen is still on, the hazard lights work, and I can open the doors and windows. These are all running off that separate 12-volt battery. For now, the car is a safe, functional shelter. But here's the catch, and it's a big one. The 12-volt battery is no longer being recharged by the main battery. It's on its own, and its time is limited. Depending on its health and the outside temperature, it could last for a few hours or die in less than 30 minutes, and at that point, the car becomes completely unresponsive. So, what's next? You can't just plug the car in if the 12-volt battery dies completely. The car's computer and charge port won't have power, so they can't wake up to start charging. This is the most critical part of this whole situation. The official Tesla procedure is to call roadside assistance. But if you were to handle it yourself, you'd first need to revive the 12-volt system. A portable jump starter is your best friend here. On most Teslas, there are external terminals behind the front tow hook cover that let you send power to the 12-volt system without even getting in the car. By connecting a jump starter, you can wake up the car's electronics. Once the 12-volt system has power, the main screen will boot up, and the charge port can open and accept a charge. At that point, you can plug in a mobile connector or have it towed to a station. Once the high-voltage battery starts charging, it will take over and recharge the 12-volt battery, putting everything back to normal. However, if you find yourself here, the best and safest thing to do is contact Tesla Roadside Assistance. They are trained for this and can get a flatbed tow truck to take you to a charger. So, what happens when a Tesla battery dies? The reality is a lot less dramatic than you'd imagine. It doesn't just stop dead. The car gives you layers of warnings. The battery icon turns yellow, then red. It suggests chargers and limits power to save energy. Even when you hit zero, it gives you a small buffer of a few miles to find a safe spot. Honestly, after doing this, I have a new respect for the car's engineering. The system gives you so much notice that running out by accident seems almost impossible if you're repaying any attention. But, and this is a big one, you should never do this on purpose. Tesla's own manual warns that letting the battery fully discharge can damage vehicle components, and that damage is not covered by the warranty. Deeply discharging any lithium-ion battery can also harm its long-term health. My advice: trust your car when it tells you to charge. Don't push it like I did. But if the worst-case scenario happens, know that you won't be suddenly trapped. You'll have warnings, you'll have time, and you'll have a clear path to get running again. Have you ever gotten dangerously close to zero in your EV? I want to hear about it. Share your story in the comments below, and for more deep dives into how these incredible machines work, make sure you're subscribed. Thanks for watching, and I'll see you in the next one.